So let's discuss the three types of radiation that we've got. We've got alpha, beta, and gamma radiation. Alpha radiation is a helium nucleus. So just like we used in that Marsden and Rutherford experiment with the gold leaf and the gold foil, this is a helium nucleus. And it is positively charged. So when an isotope, nucleus of an isotope breaks down, it can release 2 protons, 2 neutrons, which is a helium nucleus. On the other hand, we've got beta radiation, and when a radioactive isotope decays, the nucleus could release an electron, and that is beta radiation. The final one, gamma radiation, which can be released when the nucleus decays. And just had a question about whether it's the nucleus that is unstable. Yes, it is. We would call these nuclei here unstable, okay, which means they could break down at any minute and release any one of these forms of alpha, beta, or gamma radiation. A few things that we need to know about. First of all, because an electron is released, then beta radiation has a negative charge, whereas gamma is an electromagnetic wave, and that would have no charge. So one key thing that they sometimes put in exams that throws people is the idea of which ones are deflected, which means are change direction. So deflected equals change direction by a magnetic or an electric field. And you need to think about which ones are charged to be able to answer this question. So alpha particles are positive, beta particles are negative, so these are charged particles. So these are ones that can be affected by an electric and a magnetic field. So if you've got your decaying nuclei here, your alpha particles will be deflected in a field, your beta particles will be deflected, but your gamma rays will go straight through unchanged. What you need to remember is that alpha particles, because they're positive, will go in the opposite direction that beta particles will. Now we're going to talk about the types of radiation in terms of their ionizing abilities. Okay, and we're going to talk about alpha first of all. Alpha is what we call strongly ionizing. Now, because it's big compared to an electron, it's actually absolutely massive compared to an electron, it also has a positive charge, which means when it bashes into other atoms, it can rip electrons off of those, causing those atoms to become ions. That's what it means by ionizing. So that can cause a lot of damage because it's a positively charged thing, banging into atoms, and it can rip those electrons off. Compare that down, then we've got beta, which is slightly ionizing, to gamma, which is weakly ionizing. Now, I've just had a question that says, how did the electron end up in the nucleus for beta radiation? Awesome question. And so strongly ionizing to weakly ionizing. Here, we need to talk about, about how much they penetrate. That means how much they go through materials. Now, the thing with alpha, this doesn't really penetrate much at all. So it doesn't penetrate far, it doesn't travel far. It'd be absorbed by the time it gets very far in air, for example. It doesn't penetrate far. Whereas the gamma does penetrate far. So the gamma radiation is going to travel really long distances, whereas the alpha radiation won't. And this diagram you should be familiar with about which materials will stop each 3 types of radiation. So you've got alpha particles stopped by paper, beta particles stopped by a few sheets of aluminium, and gamma particles mostly stopped by lead. You'll see a little bit might still get through, but mostly stopped by lead. And it's lead which is used in hospitals, and all the nurses will stand behind that to protect themselves from radiation as well. Now, to remember this, I always remember A, B, G, and the fact that they're in alphabetical order: alpha, beta, gamma. Okay, moving on to a few uses of radiation then. We've got smoke detectors, which alpha radiation is used in. Because if you remember from before, even though it's strongly ionizing, it won't travel very far at all. Okay, so it won't penetrate very far. So actually we're quite safe unless we open this up and start accessing the radioactive material inside. because it's not very penetrating, it's got a low penetration, it won't travel very far, then we are quite safe from that. If you were to obviously access the material inside, it would be highly ionizing and quite dangerous. Here we've got the idea of beta radiation, which can be used, for example, to test the thickness of aluminium foil, because it's stopped by a few sheets of aluminium foil, so it should help to test the thickness of foil. So it's sometimes used in these foil mills. And also, these are used as tracers. So both of these actually, gamma radiation, which you'll see like this kind of symbol, is used as well as beta radiation for medical tracers. Gamma is also used for to kill cancer cells and to sterilize foods. So it will kill the cells like bacteria and things that are on foods. So here you've got the gamma rays being fired directly at a tumour. You want it to land right on the tumour, otherwise you can damage the other cells around it. The medical tracers then, just to give you an idea of the kind of thing that they might be used for. The example that they sometimes use in exam is iodine 131. Now that is an isotope that is used to check the function of a gland called the thyroid gland. And what they do is they make you swallow or inject you with this isotope, which will then be breaking down. And when it breaks down due to decay, it will release radiation. And then they can test to see where that radiation is in your body. Here, for example, they make you swallow it and use something called a Geiger counter or a Geiger-Müller tube to count the activity of that radiation. Now, this is really important. The reason why these two are good is because beta and gamma can leave your skin. Alpha, however, is stopped by paper. But if that got into your body, alpha radiation, it would not be able to get out again. And therefore, that's just going to continue to cause loads of damage inside, whereas the beta radiation and the gamma would be able to go out.